Here is an application problem on rate of change. I will give you a partial solution to it, in fact a hint how to do it, and I will not do the calculations for you. You can always use your calculator and get the answer. I'll prefer once you read the question, stop the video, write down your solution and then check with my so-called solution or the hint. A1. A firework is shot into air such that its height h in meters after t seconds can be modeled by the function h of t equals to minus 5t square plus 25t plus 3. Part A. Find the average rate of change of height with respect to time in the first 3 seconds. Part B is calculate the instantaneous rate of change of height with respect to time at t equals to 1.5 seconds. Okay. Now, here is how you should think about it. It's a very simple, straightforward question as such. When we say find the average rate of change of height with respect to time in first 3 seconds, that means first 3 will include from 0 to 3. First 3 seconds. From 0 to 1 it is the first second, 0 to 2 it is the second second, and from 0 to 3 it is first 3 seconds. Okay, so basically what we have here is you have to say h of 3 minus h of 0 over 3 minus 0. That gives you the answer, right? It's so simple as that. So h of 3 means you'll plug in 3 here, correct? You say this is equals to minus 5 times 3 square plus 25 times 3 plus 3. This is your h of 3. Let me put it in square brackets. Minus h of 0. So when I put t as 0 here, this becomes 0, this becomes 0, and we get 3, right? So I'm not writing those. They are zeros, yeah. 3 here. Divided by 3 minus 0, which is 3. So that becomes your average rate of change of height with respect to time in the first 3 seconds. Mistake which students may do is they may consider from 1 to 3. That leaves only 2 seconds. Okay, that is an error which I have seen, but otherwise this is a straightforward question. Now part 2 is calculate the instantaneous rate of change of height with respect to time at t equals to 1.5 seconds. My suggestion here is that when you have to find instantaneous rate of change at just 1 point, it is better to use centered value. Centered value, it's a continuous function. So what you can do is, you can find, because it is 1.5, we can calculate h of a point more than this and a point less than this. So we'll say 1.51. The value you can calculate as we did here, correct? Minus h of 1.49. That gives us accuracy of 1 decimal place. Divided by these two values, right? 1.51 minus 1.49. So that should give you the instantaneous rate of change at t equals to 1.5. Use your calculator, find your answer. One important thing which you should not miss here is units. So the units are height is in meters and time is in seconds. So write your answer in units. Meters per second, which is same for both average and instantaneous rate of change. Remember these things. Otherwise, there you could lose another 0.5 marks. I hope you understand. Okay? Thank you.